Good morning, everybody. I want to make a quick video kind of going over the rest of our notes about finding the roots of a polynomial equation. I know we kind of left off in a bad spot on the other day on our notes, so I'm going to kind of pick it up from there, and hopefully through this video you guys can kind of bookmark it and save it, and that way you can use this as a good reference point to come back to analyze and to review how to calculate these roots of higher order polynomials. So we're actually going to go right through these steps from our notes. First, we're going to identify the possible roots using the rational root theorem. This is actually something we mentioned at the end of class the other day. Looking down here, the possible roots are always factors of my constant over factors of my leading coefficient, which just happens to be 1. Factors of -8 are 1, 2, 4, and 8, and factors of 1 are just 1. Now, the way we read this is it's 1 over 1, 2 over 1, 4 over 1, 8 over 1. So 1 is a denominator for all these numbers. And also we have plus and minus to represent -1 and +1, etc. Well, it's great that we can identify our possible roots, but really what we're going to next is, our next step is we're going to graph in our graphing calculator. Now, in our graphing calculator, we're going to actually be able to see a literal root from the picture of the graph. So let's review how to graph these equations. So we're going to hit y equals, and that will bring us to this graphing screen. Then we have to type in the equation. It's x, use this x, not the alpha x, not like the green x. Just hit that button right there. X to the 4th power plus x to the 3rd power plus 2x squared plus 4x minus 8. So now we have our equation typed in. We go up and hit this graph button right up here. And on your screen, a graph will appear. Now visually, I can kind of tell where some of the x-intercepts are already. There's a variety of ways you can do next. I like to hit the trace button, and I kind of move my cursor and kind of get where I kind of think these x-intercepts are. Remember, those are the zeros I'm looking for. Kind of looks like it hits at -2. What I can do is I can type in -2 and hit enter. And I can see right there that -2 is on the x-axis. It's an x-intercept. Another one is +1. Another way I can view this is I can go to the table. So it's second table. And I can see 1, 0. I can also see -2, 0. So there's just some ways that you can show the zeros on the graph using a graphing calculator. Desmos is another great application that you can use to find those x-intercepts on a graph. The last method you can do is above trace, there's this word calc. So I get second, get to the calc button, and there's a little button that says 0. This function of the calculator will help you find the zeros or the x-intercepts of a graph. What it's going to ask you to do, see it says left bound. The calculator is asking you to help it form an educated guess of where this x-intercept is. So we're going to scroll, see where the blinking cursor is. I scroll to the left of the x-intercept, and I hit enter. Then I scroll to the right of the x-intercept, and hit enter. Then it says guess, I hit enter one more time, and the calculator estimates that the 0 is at -2, 0. So all these things are showing that I have an x-intercept of -2. Well, what do we do with that information? We're on to step 4. We found a 0 from the calculator. Now we're going to use synthetic division to factor out that root. Basically, what you want to do is you're going to take whatever x-intercept I got from the graph. This one was -2. And I perform synthetic division on that equation. To review synthetic division, remember we drop down a 1. -2 times 1 is -2. Add this together, we get -1. -2 times -1 is +2. Add those together, we get 4. -2 times 4 is -8. Add 4 and -8, we get -4. Lastly, multiply -4 and -2, and we get +8. Add this together, we get 0. Meaning our remainder is 0. And that makes sense. Our remainder should be 0. -2 is a factor of the function. When something's a factor, it divides in evenly. This is where some of the tricky parts comes in next. I'm going to write the factored form of my polynomial. Now you might be asking yourself, where did I get all these numbers from? Well, I'm actually getting it from the synthetic division. X plus 2 is the factored form of x equals -2, right? Think about that. When we did synthetic division, we would always write the opposite of the number for our divisor. Well, if I'm going backwards and writing in the factored form, it's the same concept. I write x plus 2. So long story short, whatever this number is out here on the left, just write the opposite of in the parentheses. This next long parentheses comes from my quotient of that synthetic division. 1x cubed minus 1x squared plus 4x minus 4. Now, I'm trying to solve this equation. Why do we do synthetic division? Well, we do synthetic division to create a simpler polynomial for me to factor. I actually don't have any strategies to factor a polynomial that it was originally. X to the 4 plus x cubed, etc. We don't have strategies to factor that. But now that is simpler. I have 4 terms here. Now I can use factor by grouping. So this is combining all those steps. I've been kind of teaching you guys one little baby step at a time. Now we're putting it all together. Okay? So now I'm going to do factor by grouping on this 4-term polynomial. Remember factor by grouping. You split it in half, take the GCF of each group. The GCF of the left group is x squared, leaving me with an x minus 1. The GCF of the right group is 4, with an x minus 1. Therefore, we put that together. X plus 2 was the original, x squared plus 4, and x minus 1. X squared plus 4 goes in one parentheses. The x minus 1, the common binomial factor, goes in its own parentheses. We're almost done. The last step of factoring is to take each one of these factors and set them equal to 0 and solve. Right? We're down here number 6. Factor and use the zero product property. X plus 2 equals 0. Well, if we solve that, we get x equals -2. Again, that's why we write x plus 2, because when we solve, we get that x equals -2. This is the same value we saw from before, and we saw in the graph. I'm going to hold off on that x squared one to the last, and I'll explain why. X minus 1 equals 0, x equals 1. We also saw that on the graph. Right? We also saw that on the graph. That was another x-intercept. Now this next one, the reason why I chose it for last, it's a little bit different when we solve this one. I'm going to subtract 4 on each side, and we get x squared equals -4. Now when I solve and take the square root, notice I'm taking the square root of a negative. This leads to imaginary numbers. X equals plus or minus. We always put plus or minus when we take a square root of something. It's the square root of -4. Well, the square root of 4 is 2. The square root of -4 is 2i. And those are actually the 4 solutions to this equation. X equals -2, x equals positive 2i, x equals -2i, and lastly, x equals 1. These are the actual roots. Now, I know that's a lot to take in. I highly recommend going back and watching that one more time. What I'm going to do with you guys is I'm going to handle one more as a group. I'll just one a little bit quicker, right? We're going to do one more as a group, and then the remaining problems you guys can use this video to solve on your own. So we look at this next one, all right? And by all means, you guys can stop the video and try this on your own, and then hit pause just to check your answer. The possible roots are factors of 8 or factors of 1. Factors of 8 are 1, 2, 4, and 8. And factors of 1 are 1. These are actually the same possible factors that we had in our last equation. Now, what I have to do is I have to graph this. So this is where it's good to know our possible roots, but really our graph is going to be the key here because it's going to tell us the actual root. X to the third plus 6x squared plus 12x plus 8. Hit graph. See on this graph over here, I can kind of see it as an x-intercept. Looks like -2. If I want to confirm that, I can go right to the table and see, oh, yep, -2 has a value of 0. That means it is an x-intercept. We take that information from the graph and we use -2 to perform synthetic division. You guys can see how important synthetic division is. That's why I had you practice it on Monday. So perform our synthetic division. This is what we get as a result. And it's -2 times 1. That's what gives us this -2. Add them together, we get 4. -2 times 4, get -8. Add those together, we get +4. We take our answer from synthetic division and we write this in factored form. X plus 2, remember x plus 2 is the opposite of this -2 we had out here. 1x squared plus 4x plus 4, that's where this parenthesis comes from. Now we're going to try to factor and solve. I can factor and solve that second parenthesis. We're looking for factors of 2. Sorry, I just gave away the answer. Factors of 4 that add up to 4. Well, that's 2 and 2. Factors of 4 that add up to 4. Notice I have the same thing over and over again. I might bring back a vocab word that we took Friday notes on. Come back to that in a second. Set each of your factors equal to 0. X plus 2 equals 0. Therefore, x equals -2. Well, we're actually going to get the same answer 3 times in a row. X equals -2, x equals -2, x equals -2. That's okay. If you recall on Friday's lesson, we talked about this concept of multiplicity. Multiplicity means you have multiple of the same answer. You have multiples, like collecting cards and you got to repeat. You have multiples. It's okay to have multiples of a solution, right? Completely okay. That is actually why the graph has this kind of distortion at x equals -2, because it has a multiplicity of 3. What I want you guys to do for this, snow day, asynchronous day, there is 1, 2, 3 more problems. I want you to try to tackle the next 3 problems. Okay? Try to tackle it using your graph. You can use Desmos or a graphing calculator to perform your synthetic division and then get into the factoring skills. If you guys have any questions, rewatch this video or reach out to me through Google Classroom. Talk to you guys later.